So, simplify, I need you to know what that means. Because simplify is just going to be the only direction there is. You need to know what your answer needs to look like to be simplified. So find the smallest base, reduce fractional exponents. It means that you also need to pull out any bases that reach the condition of the root. So if you have the third root of x cubed, you have to take out that x. Simplify also means that the radical in the denominator needs to be fixed. You need to rationalize the denominator and no negative exponents. So here's a couple of the problems that students asked about. Number 9, from your homework. So you're looking at yours. Find your homework. Number 9, 11 to the 2/5 over 11 to the 4/5 is not 1. Why not? Because they're not equal. Exactly. It's 11 to the 2/5 is not the same number as 11 to the 4/5. I don't know exactly what that number is. I would need a calculator, but I know they're not equal. So just because it's 11 over 11, it's not equal to 1. So instead, we have to use the rules for exponents, which is right here. If I have 11 as the base, I'm going to keep that base and subtract the exponent. So subtract. That's going to give me 11 to the negative 2/5, which I'm going to write in the denominator. And that's a problem. What problem is it? It's this problem. It is, there's a radical in the denominator. So here's the question. If that says 11 to the 2/5, that means I actually have, I'm going to write it really small over here. I have 1 over the 5th root of 11 squared. See the radical in the bottom when I write it like that? You see it? It's there. How many more 11s do I need for them to not be inside the radical? I have 2 now. How many do I need to be able to get out of the 5th root? I need 5 altogether. I have 2, so how many more do I need? I need 3 more. So that's the tricky part. This step in pink is what I need for you to know. If you don't have number 9 to look at because you don't have your work or you skip this problem, I need for you to write it down now because you're going to see this question again and you're going to miss it because it's hard, and I'm going to be sad because I'm spending the time right now to go through it with you. Abby says, I need 3 more. So I'm going to multiply by 11 to the 3/5 over 11 to the 3/5. And that gives me the 5th root of 11 cubed over 11 to the 1st power. And I'm just going to leave it like that because I don't know what 11 cubed is off the top of my head. So we simplified it, and then we got the square root out of the denominator. 29. 29 says 3 over the 4th root of 144. I don't know what the 4th root of 144 is. It's not special. It's a little special because it's 12 times 12, but it's not 4th root special. So what did I do? In 29, you can see in my first step, I made it 12 times 12 because I know that. In my second step, I took 12 and I made it 4 times 3. This is 4, and this is the 3, and then I did it again, 4 times 3. And now I can take things out that I have 4 of. So do you see how these 2's became this 2 on the outside? Does that make sense for you? So I got a yes. How about now I have the 4th root of 3 squared. There's a radical in the bottom. Again, this is my issue up here. I've got a radical in the denominator. If I have the 4th root of 3 squared, how many more 3's do I need? What do I need to multiply by? The 4th root of what? Another 3 squared. 4th root of 3 squared. And this pink fraction is equal to 1, and that's why I can do it. And then I do that math out, and I have 3, the 4th root of 9, over 2 times, what's the 4th root together? This is going to be the 4th root of 3 to the 4th. How much is that? 3. Now what can I do? I can multiply. I can also do some simplification. So I can go 3 cancels 3. And now I have the fourth root of 9 over 2. These are very complicated. The rules are tedious. The details are important.
Can you simplify the fourth root of 3 squared to just the
Yes,
square root of 3?
that would be so much better. So what if I did an eraser right here and said, find the smallest space like I did in my directions in the beginning? I totally could do that if I could find the eraser. Hold on. There it is. Sweet. Okay, so Zane says, why does it say the fourth root of 9? Why doesn't it say 3 times 3 to the 1/2 power? Because 3 squared to the 1/4 power is 3 to the 1/2. So much better. The 3's still cancel right here. These are regular whole 3's. And now I have 3 to the 1/2 over 2. Or square root of 3 over 2. You want to think about giving your answer in the same style that it was given in the beginning of the problem. So my original problem is over here with a radical. My best answer is over here with a radical. I definitely needed the square root of 3 over 2. Okay, looking at 47, another one of our questions. We have, I'm hoping to grab, and I can't seem to grab it. Let's see if I can do this. There we go. Okay, so 47. This is a mix of people's questions, so all kind of people ask questions. 47 has x to the 2/5 times y over x y to the negative 1/3. They are similar bases, x and y. Use the rules for division, which is subtraction. I wrote it out in the second step right here. I've got x to the 2/5 minus 1, because this is an understood 1 on the bottom. And that's going to give me x to the negative 3/5. Because I'm going to rewrite 1 is 5 over 5. That's negative 3/5. Then this one is going to be 3 over 3, because I have this 3 as a denominator. I'm going to change the negatives to a plus, because I have 1 subtract negative 1/3. So I had 2 negatives there. Now I have 3/3, and 1/3 is y to the 4/3. This problem was given to me in exponents, not a radical. So I'm just going to rewrite my final answer. The simplified version is y to the 4/3 on top over x to the 3/5 on the bottom. I'm going to keep the exponent style. So details. How we doing? Okay? 49. 49 is in radical style. Everything is to the negative 3 power. Personally, I find this kind of problem hard to do in radical style, so I'm going to put it into exponent for a minute. I have x to the 2/3 times x to the 4/6, which is also 2/3. All to the negative 3 power. What do I want to do after that? Do I want to multiply inside first or take everything to the negative 3 power? I don't care. Either's fine.
Multiply inside.
Multiply inside, which means add the exponents. We have x to the 4/3, all to the negative 3 power. That's ugly, but okay. That's x to the 4 over 3 times negative 3 over 1. That's going to be x to the negative 4. So that's going to be 1 over x to the 4th. And I don't need a radical anymore because it canceled out. 49. 51. 51, they asked us this question backwards. The direction said, can you give me a quotient whose result is x to the 3/4? So what I did was I wrote a quotient, and I have to think about things that subtract and make 3/4. So give me some sort of fraction for the top. Yep. 4/4, that's easy. And then if I subtract on the bottom 1/4, that's going to give me 3/4. So x to the 1 and x to the 1/4. That's an example that works. And you could have a lot of different examples. But how to think about the problem is they wanted a quotient, so I'm going to write it as a quotient, and then I'm going to think about what values I could put in. They're going to give me 3/4. You could have a lot of different answers for that. Okay, what else? 57. Write in simplest form implies that the simpler form is still a radical, only simpler. Simpler means reduced base, exponent, reduced exponent also, and no radical in the denominator. So, in 57, there's three things happening. We have x to the third, we have y to the fourth, and we have the cube root of everything. I cannot simplify inside the radical. X to the third and y to the fourth do not simplify. But I could think about this and separate it, and this is how I would do the problem. I would do the third root of x cubed divided by the third root of y to the fourth. Now they're easy to simplify in little pieces, little chunks that are easy to work with. What's the third root of x cubed? So just x. These cancel. They are opposite functions. How about in the bottom? How can we simplify that? We can make it 4/3, but because, and this is why I wrote this on the side, because it's still a radical, I need to keep a radical in my answer. So in this form, I need to take the y out because we have 4 of them, and then there's one left over. It's a little bit simpler, but I'm not done. The x was simplified, the y was taken out, but what's wrong with it right now? What do mathematicians think that's ugly about this?
There's a radical.
There's a radical in the bottom. So this is harder than what we did in the earlier chapter. We have to figure out how to get 2 more y's. I need 3 of them. So I'm going to multiply this. This is what we did in pink on the other problem. So let's go back to pink. Maybe the color will stick in your brain. We're going to multiply by a fraction that's equal to 1, and that fraction is going to be the cube root. Maybe. Hold on, that was not good. Okay, try again. The cube root of y, how many y's do I need?
2.
2. So Kel says we've got one over here. If I had 2 more, then I would have 3. If you were playing Go Fish and you had a book of 3, that's what we need in this problem. The root 3 says I need 3 of them. So we're going to randomly assign this problem 2 more on the top and 2 more on the bottom. And we're allowed to do that because when you multiply by 1, you haven't changed the problem. How does that help us? That gives us this, x, the cube root of y squared, over, that's tragic, over y times the cube root of y cubed. Now you probably won't write that in your homework, but it is helpful to note why we did this. We did this because now we have the cube root of y cubed, which means now we have x, the cube root of y squared, over y squared. And we cannot simplify the y in the radical with the y outside because they don't have the same root. This may not feel simplified to you. This may feel like over and above, and I totally get that. However, this is one of those like math processes that I just need for you to know how to do in case in the situation you're in, you have to be able to figure out the math and simplify it and know what that means. Yeah. 39. Oops, I think I added 2 pages. Saying what is 30